Greetings, my dear listeners. Today we begin a new journey into the search for the most unusual traces that intelligent civilizations may leave across the universe. In the past, we spoke of radio signals and attempts to hear cosmic voices. Now we turn to another frontier, technosignatures. These are the telltale signs of technology, the footprints of a technosphere created by intelligent beings. What is a technosignature? In its simplest form, it is any technological trace detectable across interstellar distances. Our own radio emissions, for example, are already a technosignature, but the range is far broader. Colossal megastructures, atmospheric alterations, waste heat from industry, or even unusual patterns of light. The idea of searching not only for biosignatures but also for technosignatures emerged in the second half of the 20th century. Scientists reasoned, if a civilization advances over millions of years, it cannot help but leave traces too vast to hide. Detecting those traces might prove more effective than waiting for a deliberate signal. A signal can be withheld, but a technosphere radiates its presence inevitably. Philosophically, this shifts our quest from seeking contact to seeking evidence of presence. We ask, which civilizations have altered their planets and surroundings so profoundly that their mark is visible from tens of light years away? If such civilizations exist, we might know of them long before any encounter. One classic example is the Dyson sphere, a hypothetical structure enclosing a star to harvest its energy. Such a construct would radiate in infrared as starlight is converted to heat. That heat could be observed. Ideas like these inspire astronomers to comb through data archives in search of anomalous stars. Another path is atmospheric analysis of exoplanets. If we find substances unlikely to occur naturally, for example chlorofluorocarbons, products of industry, that could signal a technosphere. Thus, technosignatures may be colossal or subtle, grand or nearly invisible. But let us ask, what does this say about us? For Earth already shines with technosignatures. Our radio stations, satellites, city lights, industrial emissions, all may be detectable. We ourselves are the source. In seeking technosignatures in the cosmos, we are in effect searching for our own reflection. This unites SETI with exoplanet research. Our vision broadens, not only who will send us a message, but also what traces does life and intelligence leave. It is cosmic archaeology. We seek not a letter, but footprints. Consider, perhaps we already observe alien technosignatures, but do not yet recognize them. Or perhaps none exist, which is an even deeper question: why? Thus, technosignatures open a new dimension in the search for extraterrestrial intelligence. They expand our horizons and teach us to view the universe as a place where intelligence must leave traces. In the chapters ahead, we will explore in detail the types of technosignatures and the science of recognizing them. When we think of technosignatures, the first image that often arises is of colossal engineering projects harnessing the energy of stars. One of the most famous ideas is the Dyson sphere. Proposed by physicist Freeman Dyson in 1960, it became both a staple of science fiction and a serious astrophysical concept. Dyson's reasoning was simple. As civilizations grow, their energy demands expand. Eventually, planetary resources would be insufficient. The logical step would be to capture stellar energy directly. Imagine a swarm of satellites, mirrors, or panels orbiting a star, collecting its light and converting it to usable power. To an outside observer, such a system would make the star appear dimmer in visible light, but brighter in infrared. Philosophically, the Dyson sphere changed how we think about civilizations. We began to imagine them not only as societies but as cosmic forces reshaping their environments. Astronomy thus expanded from studying stars to hypothesizing about technologies far beyond human experience. Modern scientists search for such structures. In stellar spectra, astronomers look for anomalies, excess heat with reduced visible light. One candidate was the famous Tabby's star, KIC 8462852, whose unpredictable dimming fueled speculation about megastructures. While natural explanations are likely, the idea of searching for such constructs has become part of mainstream astronomy. It is important to note that Dyson never envisioned a solid shell around a star, as often depicted. Instead, he described a swarm of orbiting satellites. This version is more feasible, though still daunting on an unimaginable scale. Consider, if somewhere a civilization has built even a partial Dyson swarm, we might detect it not because they wish to communicate, but because their activity is too vast to conceal. This is the essence of technosignatures, unintentional, byproducts of civilization itself. Philosophically, this also reflects back on us. Could humanity ever build its own Dyson swarm? If so, what kind of mark would we leave upon the universe? Thus, stellar megastructures stand among the most striking technosignatures. In the chapters ahead, we will explore other possible traces, from atmospheric industrial pollutants to the radiation of interstellar ships. When considering technosignatures, we must remember, not all traces are colossal megastructures. Some of the most compelling evidence of civilization may lie in the atmospheres of planets. Atmospheres reflect both natural processes and the activity of intelligent beings. Astronomers today already analyze exoplanet atmospheres using spectroscopy. As starlight passes through a planet's atmosphere, certain wavelengths are absorbed, leaving a fingerprint that reveals the presence of various substances. This method allows us to detect oxygen, methane, and other biosignatures, but it can also be applied to technosignatures. Which substances count as technosignatures? Chief among them are gases difficult to explain naturally. Chlorofluorocarbons, for instance, are produced only industrially on Earth. Detecting them in an exoplanet's atmosphere would strongly suggest a technosphere. Another clue lies in imbalances. Imagine an atmosphere containing abundant oxygen and methane simultaneously. These gases react quickly, so their coexistence implies constant replenishment. On Earth, this comes from life and industry. Elsewhere, such disequilibrium might also betray technology. Philosophically, this approach casts us as cosmic doctors. We diagnose distant planets by studying their breath. If one day we detect the symptoms of a technogenic condition, it will be a sensation. Interestingly, researchers already use Earth as a model, simulating how our atmosphere would appear from light years away. Signs of civilization are visible. Radioactive isotopes, combustion byproducts, industrial gases. If we find the same fingerprints on another planet, the parallel will be striking. Yet the question remains, if technospheres are so visible, why have we not found any? Perhaps civilizations are rare, perhaps they live sustainably, leaving few traces, or perhaps they vanish quickly, their signatures fleeting. Consider a planet's atmosphere is like the biography of its civilization, written in molecules. We, as attentive readers, must learn to interpret it. Thus, exoplanet atmospheres are among the most promising avenues in the search for technosignatures. In the coming chapters, we will explore other possible traces such as waste heat and unusual light phenomena that may result from intelligent activity. When discussing technosignatures, we cannot overlook waste heat. Any civilization that uses energy inevitably produces byproducts, foremost among them, heat. From a physics standpoint, this is a universal trace. Energy cannot be harnessed without generating waste heat. This makes the search for civilizations via their thermal emissions highly attractive. Physicist Freeman Dyson noted that even if a civilization chooses not to send signals, its activity will still be visible. Any advanced technosphere must process energy on such scales that it alters the spectrum of its star or planet. If we detect excess infrared emission beyond what natural processes explain, it may point to an artificial source. Modern observatories like the WISE and Spitzer space telescopes have compiled extensive infrared datasets. Scientists analyze millions of stars, searching for anomalies. For instance, if a star glows unusually bright in infrared, it may indicate structures converting starlight into energy. Philosophically, this underscores that energy is the universal language of civilizations. We may not understand their words, but we understand physics. If someone uses vast energy, they cannot fully hide the trace. In this sense, waste heat searches may be the most reliable technosignature strategy. Interestingly, Earth itself produces waste heat. Our cities, factories, and power plants radiate into space. From afar, extraterrestrials might notice our planet's unusual warmth. This strengthens the argument that we too should seek such traces elsewhere. Challenges remain. Natural processes, dust clouds, young stars, can also emit strongly in infrared. The task is to distinguish the natural from the artificial. This requires refined analysis and massive data sets. Consider, waste heat is the breath of a civilization. It reveals existence unintentionally. We may not see the beings, nor know their language, but we can feel their warmth. Thus, infrared observations stand as a key tool in the search for technosignatures. In the coming chapters, we will examine other potential traces, such as artificial light and interstellar travel. When we look at Earth at night from orbit, we see the glowing web of cities, streets illuminated by lamps, megacities shining like stars. All of this is artificial light, something nature alone does not produce. And this is another potential technosignature, luminous effects created by civilizations. Imagine, if an advanced society exists on a distant planet, it surely lights its cities. That glow could be visible from space. Astronomers have already proposed searching for such signals, particularly on transiting exoplanets. During transits, tiny spectral changes could betray the presence of artificial illumination. Philosophically, this is a moving thought. We are not searching for abstract megastructures or invisible gases, but for the light in a stranger's window. It brings the search for extraterrestrial intelligence into the realm of the intimate, the idea that somewhere, far away, a lamp also burns, and someone lives there. Researchers have modeled what level of Earth's artificial lighting would be detectable from tens of light years. It turns out that if extraterrestrials possess telescopes comparable to our next-generation instruments, they could perceive the flicker of our cities, especially where vast regions like megacities radiate strongly. Another category of light technosignatures involves lasers. We ourselves consider using powerful lasers to signal distant stars. Such beams could be seen across tens or hundreds of light years. If other civilizations employ lasers for communication or navigation, we might detect them too. There are challenges. Natural phenomena, volcanic eruptions, auroras, can produce unusual flashes. Distinguishing artificial light from natural sources is not simple. But this is the strength of science: testing, comparing, refining hypotheses. Consider, if one day we observe rhythmic, patterned light from a distant planet, how will we react? Will we be ready to say those are the lights of an alien city? Thus, artificial illumination and lasers offer another path in the search for technosignatures. They remind us that what is ordinary for us, a streetlight or a city skyline, could serve as a beacon in the cosmos. In the next chapters, we will explore even bolder possibilities, such as traces of interstellar travel. One of the boldest ideas in technosignature research is the hypothesis of interstellar travel traces. If a civilization is advanced enough, it may not only build megastructures or light its cities, but also send ships to other stars. Such vessels could leave detectable marks. First and foremost are interstellar probes. If powered by nuclear fusion or antimatter engines, their emissions might be observed. Spectroscopically, they could appear as unusual bursts or spectral lines inconsistent with natural processes. Scientists discussed the possibility of searching for flyby signals. Imagine a craft passing through our system. Its engines or power systems could produce a brief but noticeable trace. With enough vigilance, we might detect it. Philosophically, this stretches imagination. We may not only wait for messages, but anticipate travelers themselves. What if the first evidence is not a radio signal but a starship? Some link this to von Neumann probes, hypothetical self-replicating machines capable of exploring the galaxy. If such entities exist, they could leave technosignatures in the form of anomalous objects or artificial satellites. Another avenue involves colossal propulsion systems such as laser arrays. Our own Breakthrough Starshot project envisions using lasers to accelerate light sails to near-light speed. If others deploy similar methods, their beams could be detectable. Consider, spacefaring is a universal dream. If we one day glimpse the trace of an interstellar craft, it will not only be a discovery but proof that dreams can materialize. Thus, the search for interstellar travel traces expands the horizons of technosignature research. It reminds us that civilization is not only defined by its planet, but by its reach for the stars. In the chapters ahead, we will explore further signs of advanced intelligence. When discussing technosignatures, we must not overlook satellites. Earth is already surrounded by a cloud of artificial objects, operational spacecraft, dead satellites, rocket debris. From a cosmic perspective, this is a true belt of civilization, itself a technosignature. If an advanced civilization exists on a distant planet, it too should have satellites. In sufficient numbers, these could affect the way the planet reflects light. Scientists suggest artificial satellites may cause subtle but detectable differences in light curves during planetary transits. Moreover, large satellite systems like our communication and navigation constellations could leave distinctive spectral fingerprints. Imagine thousands of spacecraft covering an orbit. Such a belt would differ from natural planetary rings. Philosophically, this highlights how civilizations reveal themselves in detail. We might not see their cities, but their orbital constructs betray their presence. It mirrors our own reality. Earth is already marked by its artificial satellites. The analogy with debris is also relevant. Space junk is an unintentional technosignature. Nobody broadcasts it as a message, yet it exists and could be observed. Perhaps the same applies elsewhere. Some researchers propose searching specifically for alien satellites. Unlike megastructures, orbital systems are more plausible and probable. Any civilization developing spaceflight would likely reach this stage. Consider, what if one day we notice unusual rings around a planet that turn out not to be natural, but artificial? That would be among the clearest proofs of another technosphere. Thus, satellites and orbital constructs represent another category of technosignatures. In the chapters ahead, we will turn to even more exotic ideas, including planetary-scale engineering projects. Another bold idea in the search for technosignatures is planetary engineering or terraforming. If a civilization is advanced enough, it may deliberately alter the climate and surface of its planet, or even entire worlds. Such modifications would appear to astronomers as anomalous features. Imagine a planet with a perfectly uniform temperature across its surface. In nature, this is nearly impossible. Climates vary, with equators, poles, and seasons. But if a civilization had built a global climate control system, its effects would be evident through the absence of natural fluctuations. Such anomalies could point to artificial intervention. Another possibility is giant orbital mirrors directing starlight onto the planet, or shielding it from excess heat. These would alter the light curves of the host star and the spectrum of the planet. Such constructs could be considered technosignatures. Philosophically, planetary engineering raises questions about what it means to live in harmony with a world. For us, it means adapting. For a hypothetical advanced species, it might mean reshaping the world itself. There is both allure and danger here. We glimpse this already in our climate interventions and discussions of terraforming Mars. Researchers also consider searching for planets with unusually high atmospheric or thermal stability. If such worlds are found, they may reflect intelligent management. Nature rarely produces perfect systems. Consider, if we observe a planet with parameters too precise and orderly to be natural, will we dare admit it is the handiwork of a civilization? Thus, terraforming and planetary engineering form another category of technosignatures. They remind us that civilizations may reveal themselves not only through emissions or satellites, but through the very worlds they reshape. In the next chapters, we will turn to even grander ideas, engineering on galactic scales. When it comes to the boldest technosignatures, scientists often point to astroengineering on the scale of star systems or even entire galaxies. If a civilization has reached the levels imagined by Kardashev, it may command the energy of millions of stars. Such undertakings would not go unnoticed. One hypothetical sign is hyperluminous anomalies. Imagine a galaxy with too much infrared emission or stars behaving in unusually synchronized ways. This could indicate large-scale energy manipulation. Observations remain inconclusive, but the idea itself reshapes how astronomers view the cosmos. Another potential trace is anomalous galactic structure. Suppose stars in a region are arranged with unnatural regularity, or their motions deviate from expectations. We think of galaxies as chaotic, but intelligence might impose order. Philosophically, these ideas astound with their scale. We imagine civilizations as planet-bound. But perhaps mature civilizations regard not planets but galaxies as their homes. Their footprints would be visible across billions of light-years. Researchers also consider searching for oddities in the cosmic microwave background. A civilization using energy on galactic scales would alter thermal distributions in the universe. This, too, could serve as a technosignature. Consider, if we observe a galaxy whose properties defy natural explanation, will we dare to admit it is the work of intelligence? Or will we search for safer answers, reluctant to embrace galactic engineering? Thus, technosignatures may manifest on the largest scales imaginable. In the chapters ahead, we will return to more practical searches, including the role of radio astronomy and computational methods in analyzing signals. In the search for technosignatures, radio astronomy remains central. Radio waves were the very medium with which SETI began, but today we view radio not only as deliberate signals, but also as the incidental byproducts of technospheres. Earth itself is a powerful radio source. Our TV towers, radars, satellite links all contribute to a radio bubble expanding at light speed. To distant observers, it might appear as distinctive noise, unlike natural backgrounds. If other civilizations use similar technologies, their radio bubbles may be detectable too. Scientists develop methods to search for narrowband and broadband emissions difficult to explain naturally. Particular attention is given to fast radio bursts, FRBs. While most are likely astrophysical, some speculate that a fraction could be artificial. Philosophically, radio astronomy teaches us that civilizations always make noise. We may not hear their words, but we hear the hum of their activity. This makes radio still vital. Modern initiatives like Breakthrough analyze petabytes of data from the world's largest radio telescopes, machine learning aids in distinguishing natural from possible artificial signals. This elevates radio astronomy into big science. Interestingly, radio output may also reflect a civilization's development. A transition from analog to digital, or from radio to laser communications, could shift its emission profile. By studying such noise, we may infer technological evolution. Consider, if one day we intercept a signal clearly unlike any natural source, will we accept it as artificial, or will we cling to familiar explanations? Thus, radio astronomy remains a cornerstone of technosignature research, yet its scope has broadened. It is not only about communication, but about detecting the echoes of technospheres. In the next chapters, we will discuss computational methods and how data analysis advances this search. Today, as astronomy generates unprecedented amounts of data, the search for technosignatures relies heavily on computation. Machine learning, neural networks, and supercomputers are essential. Technosignatures are not always bright flashes. They may be faint anomalies buried in mountains of information. Every day, telescopes collect terabytes of signals. Most are natural phenomena, pulsars, quasars, atmospheric noise, but hidden within may be the subtle traces of technospheres. Humans alone cannot process this volume, but algorithms can. Modern data analysis techniques not only filter noise, but also detect patterns that humans might miss. Neural networks, for instance, can learn to identify signals deviating from typical astrophysical sources. The more data they process, the greater the chance of finding something unusual. Philosophically, this is remarkable. We entrust machines with the search for extraterrestrial intelligence. We create artificial intelligence to look for another intelligence. It is a hall of mirrors, mind seeking mind through a mediator. Some successes already exist. Distributed computing projects enlist millions of volunteers who donate processing power to analyze data. This transforms the search into a global collaboration, allowing anyone to join the great experiment. Yet challenges persist. Machines can raise false alarms, detecting anomalies that prove to be instrument glitches or interference. Verification is crucial. Only the combination of computational tools and human intuition yields reliable results. Consider, perhaps a technosignature already lies hidden in the depths of databases. We simply have not learned to see it. This makes the future of the search especially thrilling. Thus, computational methods form a new cornerstone in technosignature research. In the chapters ahead, we will discuss how next-generation telescopes and missions will further aid the quest for traces of extraterrestrial civilizations. The future of technosignature research is closely tied to the next generation of telescopes. We stand on the threshold of an era when instruments will reveal details once beyond our reach. This means the search for extraterrestrial traces will enter an entirely new dimension. The James Webb Space Telescope has already opened new horizons. Its infrared sensitivity allows the study of exoplanet atmospheres with unprecedented precision. If an atmosphere contains industrial gases or unusual imbalances, Webb may detect them. This makes it a key instrument for technosignature research. But Webb is only the beginning. In the coming decades, giant ground-based telescopes like the Extremely Large Telescope, ELT, in Chile will begin operations. With mirrors tens of meters across, they will gather enormous light, enabling detailed studies of small planets around nearby stars. This may allow the first direct detection of light technosignatures, such as artificial illumination. Future radio telescopes, including the Square Kilometre Array, SK, will also revolutionize the search. Their sensitivity will allow the detection of the faintest radio signals, currently lost in noise. If a civilization uses radio technology, SKA may be among the best tools to find it. Philosophically, this reminds us that our instruments are extensions of our senses. They give us new ways to perceive what was hidden. If civilizations exist, these tools may provide our first encounter with their presence. Interestingly, advancing instruments go hand in hand with new data analysis techniques. The more light we collect, the more information we must process. The future lies in the symbiosis of powerful telescopes and intelligent algorithms. Consider, the telescope that will first glimpse extraterrestrial intelligence may already be under construction. That moment would be transformative not only for science, but for all of humanity. Thus, next-generation telescopes and observatories hold the key to the next era of technosignature research. In the coming chapters, we will explore the philosophical and cultural consequences of such discoveries. When we discuss possible discoveries in technosignature research, it is essential to reflect on their cultural and philosophical impact. Such a discovery would not only be scientific, but a cultural shock, comparable to history's greatest paradigm shifts. Imagine, one day we find compelling evidence of a technosphere on another planet, be it industrial gases, a megastructure, or artificial light. From that moment, humanity would never be the same. We would no longer be the only known intelligence in the universe. Philosophers call this a cosmic paradigm shift. We are used to seeing ourselves as unique, central to history, but if intelligence is widespread, we must reassess our place in the cosmos. This could inspire humility as well as wonder. History offers precedents. When Copernicus showed Earth orbits the sun, it overturned our worldview. When Darwin explained the origin of species, it reshaped our understanding of life. The search for technosignatures may spark a third revolution, a cosmic one. Reactions could vary. For some, it would bring hope. We are not alone. For others, it could provoke anxiety. What if they are dangerous? Philosophically, this raises the question of the universality of intelligence. If it arose beyond Earth, then it is a natural outcome of the cosmos. We are not an exception, but part of a larger order. Consider, perhaps the discovery of technosignatures would unite humanity. Compared to other civilizations, our internal divisions would seem trivial. We would become one species entering into dialogue with the universe. Thus, the search for technosignatures carries cultural as well as scientific weight. In the chapters ahead, we will explore how humanity might prepare for such a discovery and what scenarios could unfold. When reflecting on possible scenarios of detecting technosignatures, we must consider not only the scientific but also the social dimension. The discovery of extraterrestrial civilization would provoke profound reactions, and humanity must be prepared. Scenarios vary. Suppose we detect industrial gases in a distant planet's atmosphere. This would be sensational but not threatening. We would have time to process the discovery and adapt gradually. This could be called a quiet scenario. Another case would be a direct detection of a powerful signal or even a spacecraft. That would be shocking. Reactions could range from excitement and hope to fear and panic. It would mean that the civilization not only exists but is active. Philosophically, this raises questions of readiness. We speak of contact, but in truth it would be a clash of worldviews. How ready are we to accept that we are not the center of the universe? How capable are we of encountering another intelligence without fear? History shows that such meetings on Earth often brought conflict. Different cultures meeting led to misunderstanding and violence. Yet perhaps space will offer a chance for a new kind of dialogue based on cooperation rather than conquest. Interestingly, protocols already exist for extraterrestrial signal detection. International bodies discuss procedures, who announces discoveries, how to verify them, how to avoid false alarms. This demonstrates growing seriousness. Consider, if tomorrow a credible technosignature were announced, how would your life change? Would faith, politics, science shift? Would the world become more united or more anxious? Thus, detection scenarios involve not only science, but society. In the next and final chapter, we will reflect on the future of the search itself and what our yearning to listen for others reveals about us. And so we arrive at the conclusion of our journey through technosignatures. Across these chapters, we have explored megastructures and industrial gases, artificial lights and satellites, interstellar voyages, and even galactic-scale engineering. All of these are possible hints that intelligence is not confined to Earth. But the finale must be more than a review of facts. The search for technosignatures is not just science. It is the expression of humanity's deepest longing to understand its place in the cosmos. We are searching not only for others, but for ourselves reflected in the mirror of the universe. Philosophically, the search for technosignatures is a new kind of astronomy of hope. We gaze at the stars and ask, is someone out there? Even without an answer, the question itself transforms us. It makes us braver, more open, more human. And already we are producing our own technosignatures. Earth's radio emissions, the glow of our cities, the belt of satellites, all of these could be noticed from afar. In a sense, we are already speaking into the cosmic void, even if no reply has come. Consider, one day we may see a faint trace, an unusual gas, a strange emission, or the shimmering light of a distant city. At that moment, we will know we are not alone. That day will mark the dawn of a new era, when humanity looks at the stars not only with curiosity, but with kinship. The finale must be inspiring. We may not know whether we will ever find technosignatures, but the search itself is already part of our destiny. It proves that humanity does not remain confined to its planet, but reaches toward the infinite. The journey may be long, filled with doubts and disappointments, yet it leads to the greatest revelation, the understanding that the universe is not empty, but a community of worlds in which we seek our place, and perhaps one day we'll find it. Thank you, my dear listeners. May this quest inspire you as deeply as it inspires the scientists who lift their eyes to the stars each day.